hit record. So we are recording. Okay, y'all. So today what we're going to do, we're going to go over 4.3, which talks about two ideas. One of them is called the greatest common divisor, and the other one is called the least common multiple. So we're going to kind of bounce back and forth between the two ideas throughout section 4.3. So let's talk a little bit about the greatest common divisor. It says, consider the following problem. There's two fourth grade classes at Haven Elementary School. Class 4A has 24 students. Class 4B has 30 students. During recess, the two classes will play as many games with each other, but they have to pick teams based on the following rules. Okay, teams must consist of students from the same class. All teams must be of equal size, and every student must be on exactly one team. And teams should have as many students possible. So we want to know how many teams can be made and how many students will be on each team. So let's do this. We have two classes. The first class has 24 students and the other one has 30. So what we're trying to do is we want to make teams from each class so that there's the same number of students on each team. So one thing we could always do is we could say, look, we could make teams of one, but that's kind of a boring team. You know what I mean? Because there's nobody else that you're not gonna have any teammates. But we could say, look, we could have teams of two. And how do I know that? Because 2 goes into 24, 2 goes into 30, right? And so then the next question is we might say, well, look, could we have teams of 3? Does 3 go into 24? Yeah, it does, right? It goes in 8 times and it goes into 30. Remember, what we're trying to do, y'all, we're looking for the teams that are going to have as many students as possible. So I know we could have done 1, but that's kind of a boring thing. We could do 2, we could do 3. If I wanted to check, say, 4, I would have to know, does 4 go both into 24 and into 30? Well, it goes into 24, but it doesn't go into 30, right? So I can't use teams of size 4. So if I did the same thing with 5, 5 does go into 30, but it doesn't go into 24. So then the next one I would have, y'all, would be 6, right? And so we're going to have teams of 6. So how many students will be in each team? There'll be 6 students on each team. And then we want to know how many teams can be made. So from the class 4A, which has 24 students, well, 6 goes into 24 4 times. So there'll be 4 teams there, right, for that class. And then class 4B, which has 30 students, if we take 30 and divide it by 6, then that one will have 5 teams, right? So in essence, y'all, what we found here, that number 6, is what we call the greatest common divisor. It's the biggest number that can divide both into 24 and into 30. So a lot of times when I think a lot of times students kind of confuse what's the difference between a greatest common divisor and a least common multiple. And sometimes we get those two ideas confused, but the greatest common divisor is the biggest number that'll divide into both the two numbers that we have. Or sometimes we have 3 numbers, or sometimes we got 5 numbers, however many we have. Okay. So we have the definition right here. It says the greatest common divisor, or sometimes they call it the greatest common factor. It's the same idea, greatest common divisor, greatest common factor of 2 whole numbers, A and B, not both 0, is the greatest whole number that divides both A and B. Okay, so y'all, one of the things, especially if you're going to teach more like elementary school age, so not necessarily 7th or 8th graders, but maybe something like anywhere between 1st and say 5th grade, you guys are probably going to use what they call manipulative. So it's like little physical things that you pass out to the kids, right? And you're trying to, because we're visual learners and a lot of people are learners when they kind of feel stuff in their hands. So there's a method called the colored rods method. It says we build a model of 2 or more non-zero whole numbers with colored rods to determine their GCD. So it says here, for an example, to find the greatest common divisor of both 6 and 8. Oh, come on, pen. Here we go, 6 and 8. What they do is they have these kind of colored rods. And what they say is, look, if I'm trying to get to a length of 6 and a length of 8, we can use rods of length 2. Okay, I know they didn't really write it in here, but those are supposed to be rods of length 2. And if I have 3 of those, I can get my 6 colored rod. And if I have 4 of those, I can get my 8 length rod. Okay. So that's why they're kind of, and they kind of go through a lot of explanation, but they're basically saying the greatest common divisor is 2. Meaning if you wanted to build like a stick of length 6, you could use sticks of length 1, you could use sticks of length 2, you could use sticks of length 3. Same thing for 8. You could use sticks of length 1, you could use sticks of length 2, you could use sticks of length 4. But you're looking for the one that you can build both of them with, okay? And the biggest one you can build both of them with. So yeah, we could use little blocks of length 1, but we could use blocks of length 2, and that's going to be bigger, okay? So let me kind of keep scrolling along here. And there's something called the intersection of sets method. So the intersection of sets says if we wanted to find the greatest common divisor, what we're going to do is we're going to break down our numbers. And then we're going to find the numbers that they have in common. And we're looking for the biggest one that they have in common. And so they kind of did it here for 20 and 32. And guys, I'm going to come back and we're going to do some problems where we actually do it ourselves. But that's sort of the process, okay? So now we're going to talk about something called the least common multiple. Okay, so I want to kind of look at this example here because we're going to do a problem a little bit later on that's similar. And it says, consider the following problem. It's Morgan's birthday and we need to buy some cups and plates for the party. Plastic cups are sold in packages of 8 and paper plates are sold in packages of 12. What's the least number we need to buy to have an equal number of plates and cups? Okay, so if cups come in packages of 8 and plates come in packages of 12, what we're going to do, y'all, we're going to look at the multiples of 8, okay? So again, I'm just going to scroll back over here, y'all, real quickly to my Blackboard page because what I want to do, I'm going to look at my multiplication chart, okay? So we're looking for when we have cups that come in packages of 8 and plates that come in packages of 12, what we do, y'all, we start looking at the multiples of 8. So if we had 1 pack, we'd have 8 cups. If we had 2 packs, we'd have 16 cups. If we had 3 packs, we'd have 24, so on and so forth. And then we would do the same thing for the 12, right? If we had 1 pack of plates, we'd have 12. If we had 2 packs, we'd have 24, so on and so forth. What we're looking for is what's the least number of cups or plates I have to buy so that we have the same amount? That's what we call the least common multiple. So I'm looking at this number right here and this number right here. Because even though there are other multiples, like let me see if I can find one, like here's 48, right? And there's probably another one around here. Look, here's 96, right? But we're looking for the smallest one. So the smallest number that they both have in common, y'all, would be 24. So if I scroll back over here, if you notice, this is what we call the least common multiple, and that least common multiple is 24, okay? And so again, there's kind of like an intersection of sets method that they have here, and they look at the multiples of 8 and the multiples of 12, and then they say, okay, what's the smallest one there, right? Okay, so I'm going to show y'all a couple of ideas here, y'all. What we're going to do is we're going to find the greatest common divisor and the least common multiple for each of these following groups using what we call the intersection of sets method. Okay, so first thing I want to do here, y'all, I want to break down the number 50. Can anybody tell me any 2 numbers besides 1 and 50 that multiply to 50? 5 and 10, perfect. Okay, we can't break down 5. Can we break down 10? 2 and 5, okay? So we're going to stop right there. Let's do the same thing with 20. What 2 numbers multiply to 20 besides 1 and 20? 2 and 10, good. We can't break down the 2, but we can break down the 10 into 2 and 5, right? Okay, so this is what we're going to do, y'all. We're going to draw 2 circles, and those circles are going to overlap. This is going to be my circle for 50, and this is going to be my circle for 20. What I want to do here, y'all, is I want to look at these numbers here, and I want to ask you, do they have any numbers in common? What are the numbers that we have in common at the ends right here? Between those numbers and these numbers, which ones do we have in common? The 2 and the 5. Okay, great. So look, y'all, The 2 and the 5 is going to go inside here. Why are they going to go in there? Because they have them in common. That's what the intersection of sets means. That's what where we overlap. Okay, now I want to show you something. Look, y'all, for the 50, if we took away the 2 and we took away the 5, we're still left with another what, though? We're still left with another 5. Now, that 5 is going to be in the 50 circle, but it's not going to be in the 20 circle, okay? Now, if we want to find the same thing for 20, look, we already took away the 2 and we already took away the 5, but we're still left with another 2. So I'm going to put that 2 right here, okay? Now, I'm going to show you how we can find the GCD. So the greatest common divisor between 50 and 20 is going to be the numbers that we have in common when we multiply them. So 2 times 5, that's going to give me 10. Okay, that's going to give me my greatest common divisor. Where the two sets, the numbers that where they overlap, that's going to be my greatest common divisor. Now, if I want to find my least common multiple, what I'm going to do, y'all, every number that I see in those circles, I'm going to write them down. So I have a 2 and I have a 5 because I have those in the middle, but I also have this 5, so I'm going to go ahead and write it down. And I have that 2, so I'm going to go ahead and write that one down. Okay. And now we're just going to multiply straight across. So 2 times 5 is 10. 5 times 2 is also 10. So 10 times 10, everybody agree, is 100. And we found both our greatest common divisor and our least common multiple. And this is going to be my process every single time, y'all. I'm just going to draw my 2 circles, and I'm going to break down my numbers. And the numbers that we have in common are always going to go inside the middle of the circle. And then the numbers that are left over will go on the other part, okay? So look, let's try the same thing for 63 and 36. Guys, I wish I would have given you guys more room. When I made the notes, I didn't realize it was going to take this much space, so I apologize about that. But look, we got 63 and we have 36. Okay, so again, y'all, I want to break down these 2 numbers. Does anybody know any 2 numbers that multiply to 63? 7 times 9, excellent, good. Now we can't break down 7, but we can break down 9 into 3 and 3, right? Okay. What about 36? Anybody know any numbers that multiply to 36? What do y'all think? Maybe 6 and 6? And then we can break down each of those 6s, y'all, into 2s and 3s, okay? So look, just like we did before, I'm going to draw 2 circles, okay? So I have 63 and I have 36, okay? Now, first thing I'm going to do, y'all, I'm looking at these numbers right here, okay? Do we have any numbers in common? What do you think? Yeah, we got 2 3s, right? So look, y'all, those 2 3s are going to go right there, okay? So look, if I took away this 3 and I took away that 3, I'm still left with a 7 over there, right? And if we took away this 3 and we took away that 3, we're still left with a 2 and another 2 right here, okay? So now, my greatest common divisor between 63 and 36, y'all, is going to be the numbers that we have in common, which is 3 and 3. That's going to give me 9, right? Now, if I want to find my least common multiple, we'll do the same thing. Between 63 and 36, we're going to take our numbers that we had in common, but we're also going to take the other numbers that we hadn't used. Well, we hadn't used the 7 and we hadn't used those 2 2s. So, y'all, I'm just going to use my calculator right here, and I'm going to say, look, 3 times 3 times 7 times 2 times 2 again is 252. Let me make sure I did that right. Clear it out. So 3 times 3 times 7 times 2 times 2. Yeah, 252. Okay. And we got our numbers. Okay. So this is a game I'm going to play every single time, y'all. Okay. So look, we got a third one here, and it's 8, 24, and 64. So now I actually have 3 numbers. I'm going to do the process the same way. 8, 24, and 64. Okay, so look, let's write this out. 8, 24, and 64. Okay, so 8, we all agree, is 2 times 4. and 4 is 2 times 2, okay? And then 24, anybody know any numbers that multiply to 24? 2 times 12, good. And then 12 is, say, 2 and 6. And then 6, y'all, is going to be 2 and 3, okay? What about 64? Anybody know any numbers that multiply to 64? 8 and 8, right? Now, guys, didn't we already break down 8 before? And each of those 8s had 3 2s. So I'm going to do this. 1, 2, 3. 1, 2, 3. Okay. Now, y'all, before I was drawing 2 circles because I had 2 numbers. Now I have 3 numbers. So I'm going to go 1, 2, 3. I'm going to draw 3 circles. I'm going to try to make that a little bit nicer. I want to have enough space between each of my circles. Okay. Here we go. Okay. So look, y'all, I'm just going to write my numbers kind of in order: 8, 24, and say 64. Okay. Now, again, y'all, I'm looking at the numbers at the ends of my little trees here. Okay. So, first question: do all 3 numbers have something in common? They have 3 2s, right? Okay. So look, y'all, this is how I'm going to do it. I'm going to put those 3 2s, 1, 2, 3, where they all overlap. Okay. So there's my 3 2s. Okay, so look, for the number 8, y'all, we scratch out the 3 2s. There's nothing else for me to write over here. Okay. For 24, we're going to scratch out the 3 2s, but look, we still got a 3 that's going to hang out over there. And then for 64, if we scratch out those 3 2s, we still have another 3 2s over here. Okay. All right, so now let's go ahead and find the greatest common divisor between 8, 24, and 64. It's going to be 2 and 2 and 2, which should just be 8, right? Because it's those numbers right there. And then if we're going to find the least common multiple between 8, 24, and 64, we're going to take all the numbers and multiply them together. So we got 2 and 2 and 2, and a 3, and another 2, and another 2, and another 2. So let's see. Let me clear this out. So 2 times 2 times 2 times 3 times 2 times 2 times 2. And I'm coming up with 192. Okay. What do you think? Is it making sense on how we can find the greatest common divisor and the least common multiple? And again, y'all, all we're doing is breaking our numbers down, throwing them in our sets, looking for the ones that we have in common to do the intersection of sets for the greatest common divisor, and then all of them sort of put together like the union would be our least common multiple. All right, I think there was one more, so let's go ahead and do the last one. It's 3 and 4. So that should be pretty easy, you guys, because we got really small numbers, right? So 3 and 4. Well, 3 just can't be broken down. It's already prime, it's 3. But 4 is 2 and 2. So look, y'all, here's 3, here's 4, okay? So with 3, or I'm sorry, first question, look at that number and look at these. Is there anything in common? No, there isn't, right? So there's not going to be anything that I'm going to put in there, okay? I'm not going to put anything in the middle. So if I don't put anything in the middle, then the 3 is going to go here and the 2 2s is going to go there. Now, y'all, when we don't have anything in common, we can always say, you know what, there's one number in common, and that number is going to be the number 1, okay? Because we can really divide them both by 1, right? So my greatest common divisor between 3 and 4 is going to be equal to 1, okay? And then our least common multiple between 3 and 4 is going to be 3 times 2 times 2, which should just give us 12, okay? Yeah, so when there's nothing in common, y'all, we can always drop into 1 in the middle, and there's our greatest common divisor, okay? All righty. So let me kind of scroll back over here, and let's keep scrolling on here. Okay, y'all, we're going to do the same thing here. It's basically the same process, okay? We're looking for the greatest common divisor between the numbers 180 and 168, okay? So if we were finding the greatest common divisor between 180 and 168, excuse me, I want you to notice something here, y'all. The number 180 has already been broken down. It's right here. Same thing with 168. Remember what it is we're looking for. The greatest common divisor says, what numbers do we have in common? Well, we have the 2's in common, we have another 2 in common, and we have a 3 in common. So 2 times 2 times 3 should give me something like, what, 12? Sorry about the noise, y'all. Okay. And if you notice, y'all, when they broke it down, they kind of grouped it kind of neat. So they said, look, we got 2 2's and a 3 in common, right? Now, if we were going to find our least common multiple, then what we would do is we'd say, look, we're going to take those numbers, which really was already 12. Now, I'm going to take the numbers that I still have left over. So 3 and 5 from here, and 2 from 7 from there. Wow, that's really loud. Okay, and then I'm just going to multiply, y'all. So I'm going to go 12 times 3 times 5 times 2 times 7, and coming up with a pretty big number, 2520. Okay, and there's my least common multiple, and that's doing the prime factorization method, right? But y'all, when we did the intersection of sets, we really did find the prime factorization. Okay, I think the nice thing about doing the intersection of sets method is that it's visual. You can kind of see, we're going to put the ones that they have in common in the middle. That's going to be my greatest common divisor. Those, along with all the other numbers, is going to give me my least common multiple. But in essence, we're really doing the same thing here, okay? Okay, so I'm going to go through the same process for each of these problems. I wish the numbers were a little bit smaller. I don't know why they gave us such huge numbers. But we'll go through the process, y'all. I hope it doesn't take us too long. But let's do it like this. Let's take 60. Anybody know any two numbers that multiply to 60? 2 times 30, perfect. So y'all, going by 2's is really nice. Oops, man, I can't even write today. Going by 2's is really nice because you're starting off with small numbers. What about 30? 3 and 10. And then 10 is going to be 2 and 5, right? So 60, y'all, is going to have 2 2's, a 3, and a 5, okay? Now, I'm going to play the same game, y'all, for 792. I'm going to use Erica's method. I'm going to say, look, let's divide it by 2. Why? We know we can divide it by 2. So look, 792 divided by 2, 396. Okay. We can still play that game. We can divide it by 2 again. Okay. So 198. We can divide that by 2 again. 99. I got 99 problems, right? Okay. Now, with 99, anybody have any ideas how we could break that down? 9 and 11. Okay. Now, I can't break down 11, and I can't break down those 2's. That's okay. But we can break down 9 into 3 and 3, right? So look, y'all, now I'm going to have 792. So we have 1, 2, 3. We have 2 3's, and we have an 11. Okay. Okay. So let's first find the greatest common divisor between 60 and 792. Okay. So I'm going to start matching my numbers up. So far I got a 2, I got another 2, and we got a 3. So 2 times 2 is 4, times 3 is going to give me 12. Okay. Now, if I want to find my least common multiple between those two numbers, I'm going to take that number 12 that we already used, and I'm going to say, okay, what else do I still have left over? Well, I got that 5. I have this 2, this 3, and that 11 over there. So this 2, this 3, and that 11. Okay. And so I'm going to do the same thing here, y'all, and I'm going to say, look, 12 times 5 times 2 times 3 times 11 is 3960. And there is our least common multiple. Okay, so guys, one thing I want to emphasize about the least common multiple. Remember a minute ago when I showed y'all on the multiplication table when we were finding it for 8 and 12, we were looking at the multiples of 8 and we're looking at the multiples of 12, and we'd say, look, 24 is the first one we have in common. What we just did right now, y'all, for 60 and 792, if my multiplication table had the number 60 somewhere over here, and it had the number 792 way down there, right, further to the right, when we would start to scroll down to find the first number that we would have in common, the first number we would have in common wouldn't be until 3,960. That would be the first one we have in common, okay? So look, y'all, I think we have kind of understanding the process. I don't necessarily want to do all 4 of these, but I'm going to do part C because it does have 3 parts. And then, I don't know, we'll do part D, okay? I'm going to go ahead and skip part B for right now, just because, again, I think we have the idea. But let me do these 2 parts here. Okay, so 96, 1764, and 630. Okay, so first thing is, with 96, I like that idea of dividing it by 2. Makes it easy. 2 and 48. We can divide that by 2 again, and that's going to give me 24. We can divide that by 2 again. That's going to give me 12, 2 and 6, and 2 and 3. Okay. So we have 1, 2, 3, 4, 5 2s and a 3. Okay. So there's 96. Okay. The next one we had, y'all, was 1764. Wow, it's a big number, but it's all right. This is exactly why we have calculators. 1764, let's divide it by 2. 2 and 8, 82. Let's divide it by 2 again. Okay, 441. Now, y'all, I can't divide 441 by 2. So if you remember, we talked about this on Monday. We had a list of prime numbers. After 2, the next prime number I have, y'all, is 3. Hey, 3 worked. So this is 3 and 147. I'm going to try that again. I'm going to try, can I divide it by 3? Yep, 3 and 49. And I know 49 is 7 and 7, right? Okay. So look, 1764 has 2 2s, 2 3s, and 2 7s. Okay. And I believe there was another number, 630. Okay. Let's take 630. Okay. I'm going to divide it by 2. 315. Okay, I know I can't divide that by 2. I'm curious, can I divide it by 3? Yeah, we can. 3 and 105. Okay. I don't know. Let me see. Can I divide that by 3? Yep. 3 and 35. And I know 35 is 5 and 7. Okay. So for 630, y'all, I have 1 2, 2 3s, and a 5 and a 7. Okay. Okay, now I'm going to zoom out because I want to try to see if I can get all those numbers on my screen. Okay. Now, to find the greatest common divisor between, what was it, 96, 1764, and 630, I'm going to start matching up the ones that we have in common. Okay. So let's see. I got 1 2 that we can take from all of them. It looks like we can take 1, 3 from all of them. So what's 2 times 3? 6. That's the greatest common divisor. That's the biggest number, y'all, that's going to divide into all 3 of those there, okay? So remember, greatest common divisor is the biggest number that you can divide into 96, 1764, and 630. Now, if we're going to find the least common multiple, okay, least common multiple, y'all, is going to be probably a much bigger number, okay? So look, first thing I'm going to do, I'm going to write the 6. Now, if I took away the 2 and the 3 here, I'm still left with 4 2s. So I'm going to go 1, 2, 3, and 4, okay? Let's see. Let me make sure. I want to make sure I'm telling you all the right thing. Okay. Okay, so sorry guys, I got like a little brain cloud or something right there. Okay, when I'm finding the least common multiple, what we're gonna do, this is me making a little boo-boo here. Let me come back and fix this. Least common multiple. When we're finding the least common multiple, I'm gonna look at the 3 numbers that I have right here. 1, 2, and 3. Okay, I'm gonna say, which one has the most 2s? So which one up here has the most 2s anyway? 96, right? How many 2s do I have total in this number? How many 2s do I got right there? 5. 1, 2, 3, 4, and 5. Okay. Next thing we're going to say is, which one has the most number of 3s? Well, this one does, right? There's 2 there and there's 2 there. So the one that has the most number of 3s, y'all, should be those, right? Because there's more 3s here than there are over there. Okay. And which one has the most 5s? This guy does. So there's a 5 right there. And then which one has the most 7s? This one does. Okay. So let's try that out and let's see what we end up with. Okay. So I'm going to take, I got 1, 2, 3, 4, 5. So 2 times 2 times 3 times 4 times 5 is 32. Times 3 times 3 times 5 times 7 times 7 again, 70,560. Okay. And that right there, y'all, is going to be my least common multiple. Okay. I'm going to take a quick look. I want to make sure that I told you all the right thing on this one here. Make sure I told you guys the right way to do this one here. I'm just going to check real quick, y'all. So we had 2 and 2 and 3, and then we had another 2, good, another 3, good, and the 5 and the 11. Yeah, we were good here. So, y'all, just to kind of give you an idea here for this one, just want to make sure I was telling you all the right way. When I look at my numbers here, I say, which one has the most 2s? So this one does. So there's 3 2s. And this one has the most 3s. And that one has the most 5s and the 11. And I wish I wouldn't have erased it. Maybe you guys can tell me what answer we came up with for the one we did a little while ago. Did we come up with 3960 for the one we did a little while ago? Did we get the same thing? Okay, yeah, so we got the same answer. Okay, 3960, okay. All right, so y'all, look, let's do one more. Let's do part D just again to make sure that we're doing this right. So 1125 and 1350. Okay, So again, y'all, I know it takes a while to do 1125 and 1350. Okay, so 1125. So y'all, the first thing I'm gonna do, 1125. I'm gonna try, I know I can't divide it by 2. I'm gonna check 3. 3 works. 3, excuse me, 3 and 375. Okay, I'm gonna try 375. I'm gonna try 3 again. Still working. Okay. 125. I'm going to try that by 3 again. It didn't work. Okay. So if I can't divide it by 3, the next prime number I have, y'all, is 5. 5 and 25, and 25 is 5 and 5. Okay, so look, let's do this. We got 1, 2, 2 3s, and we have 1, 2, 3 5s, and there's my number. Okay. Now let's take 1350. Let's do the same thing. Okay. I want to see if I can break that down. 1350. I know I can divide it by 2 because it's even. 2 and 675. Okay. Can I divide 675 by 3? Yes. 3 and 225. Okay. I'm just going to keep playing this game, y'all. I'm going to try to divide it by 3 again. 3 and 75. I know I can break 75 down into 3 like 3/4, and then that's 5 and 5. Okay. So look, we have a 2. We got 1, 2, 3, 3 3s, and 2 5s. Okay. So now, first thing we're going to do, we're going to find the greatest common divisor between 1125 and 1350. Okay. So what I want to know, y'all, what numbers do we have in common? What, 2 3s and 2 5s, right? Okay. So if I multiply this out, let's see, 3 times 3 times 5 times 5, 225. That's the biggest number that divides into both of them. Okay. So now let's go ahead and find our least common multiple. Okay. So let's see, if we took away the 3s and the 5s, what else are we left with? So that's 225. We're still left with this 3 here. We're still left with this 2 right here. And we're still left with that 5 right over there. Okay. So I'm just going to multiply those guys out again. So times 3 times 2 times 5. 6,750 is going to be my least common multiple. Okay. 6,750. Okay. So again, y'all, I'm hoping that as we're going through these problems, it's not that it's hard, it's just that it's tedious because you got to break the numbers down. But can you do it? Yeah, you can do it. It just takes a little bit of time to do. Okay. Now, y'all, the only thing I will say is when you're doing these problems, just take your time. You know, if you make a mistake, it could be when you were breaking your numbers down, you just broke them down the wrong way. Okay. All right. So let's keep moving along here, y'all. Okay. So the next part here, y'all, there's a little theorem here, and it says if A and B are whole numbers where B is not 0 and A is bigger than B, then the greatest common divisor between A and B is the remainder and B when R is the remainder when A is divided by B. Okay, so I'm going to explain what this means. We're going to look at the two numbers that we have right now. Okay. So the two numbers, y'all, are 2,945 and 15,635. We want to find the greatest common divisor using this thing called the Euclidean algorithm. Okay, so the first thing it says is that the number A has to be bigger than B. So y'all, I would say A is going to be my number 15,635, and my number B is going to be the number 2,945 because A needs to be the bigger number. Okay. What we're going to do here, y'all, is we're going to start dividing, okay? I'm going to take 2,945 and I'm going to divide it into 15,635. Oops, 35, not 4. Okay. Now, y'all, I'm going to use my calculator for this, okay? And I want you to notice, I'm not using any kind of a special calculator here. I'm using a real plain Jane one, right? So look, 15,635. We're going to divide that by 2,945. It's probably not going to go in nice and pretty, and it doesn't. It goes in 5 times with some change left over. So what I'm going to do is I'm going to put my 5 right here. If I wanted to know what that change would be, I'm really taking 5 times this number. So let's do that. Let's take 2945 and let's multiply it by 5, okay? And that's given me 14,725. I'm going to write that number right here, y'all, just like we used to do back in elementary school. And if you remember what we would do now, we would subtract, okay? So look, let's go ahead and do that. Let's take 15,635 minus 14,725. And I'm coming up with 910, okay? Okay, what we're going to do now, y'all, we're going to take this number and we're going to divide it into the smaller number that we ended up with, okay? So look, I'm going to play this game again. I'm going to take 910 and I'm going to divide it into 2,945. Just like I did before, y'all, 2,945 divided by 910. I know it's not going to go nice and neat. I'm going to play this game a few times, but it goes in about 3 times. So look, y'all, I'm going to put a 3 right here, and I want to figure out what's 3 times 910. So 910 times 3 is 2730. So right here, y'all, I'm going to put a 2730, and we're going to subtract, okay? So 2945 minus 2730 is giving me 215, okay? I'm going to play this game again. I'm going to keep dividing. I'm always going to divide my remainder by the previous remainder, okay? So, and I'm going to tell you when it is we're going to stop, okay? So look, let's do this one more time. Let's take 910 and let's divide it by 215. Okay, again, I know it doesn't go nice and neat, but it goes in about 4 times. So I'm going to put a 4 right here, okay? And I want to figure out what's 215 times 4? 860. And I'm going to subtract again. 910 minus 860. 50, okay? That's my remainder. I got to keep playing this, y'all, until my remainder is 0, okay? And I know it takes time. Oops. Okay, so now I'm going to divide again. I'm going to say 215 divided by 50. 4 times, okay? So that's going to give me 200, and that's going to be leaving me with 15. Okay. Well, still got a remainder, so I got to divide again. 15 into 50. So 50 divided by 15, 3 times, and that's 45, okay? And I'm going to subtract, that's going to give me a 5, okay? Now, last time here, y'all, hopefully. 5 going into 15. How many times is it going nice and neat? 3 times. Okay, now my remainder is 0. Whew, that was a lot of times to divide, okay? But this is what the Euclidean algorithm says. Whatever number you got here that gave you a remainder of 0 is going to be your GCD. So I'm going to come back over here and I'm going to say my GCD is equal to 5. Okay, that's the biggest number that divides into both of them. Okay. All right. So kind of tedious. I don't want to lie. It is tedious to do, but hopefully it makes sense as we go through it. Okay. Okay, so let's try another one here, y'all. We're looking for the least common multiple of the set of numbers. Okay, so just like we did before, we've done a problem like this before. Let's take 6. 6, I know I can break down into 2 and 3. Okay. 18. 18 I know is 2 and 9, but that 9 breaks down into 3 and 3. So this is 2 and 3 and 3. And then 12 I know is 2 and 6. And that 6 is 2 and 3. So this is 2 and 2 and 3. Okay. Okay, so we're going to find our least common multiple. Remember, y'all, the way we can find our least common multiple, let's first find the numbers that we have in common. Do you guys agree they all have a 2? And then would you all agree that they also have what else? A 3? Okay. So then we're going to say, what's left over? A 2 right here and a 3 right there. And here's my least common multiple, right? And so I want to show you something, y'all. 2 times 3 is 6. 2 times 3 is 6 again. So my least common multiple is 36. Now, right now, y'all, I'm teaching a class, Math 100. I don't know if anybody here had to take Math 100, but it's a class, it doesn't count for credit, and it's a class because those students weren't really ready for college math yet at this point. And so when I do this problem in my Math 100 class, I have them use the multiplication table. So I want to show you something. I'm looking at 6, 18, and 12. Y'all, if I were to come back to my multiplication table, let me scroll over here, let me move it this way. I'm looking at 6, 18, so here's 6, here's 12, and here's 18. So if I start going down, 6, 12, 18, 36, 42, and so on and so forth, 12, 24, 36, right? 18, 36, I can see, look, 36 right there, 36 right here, and 36 right here. And that's the first number that we have in common. And what my students in Math 100 appreciate is that it's visual. You can just look at it, and then you can find the least common multiple, okay? So y'all, the reason I'm telling you this is when you're doing your homework, use the table, right? The table is visual. And I think especially a lot of us are visual learners. We look at something and we're looking for that number that we have in common and what's the smallest one. And using that multiplication table helps me a lot. And that's one of the reasons, y'all, that I gave you guys a 20 by 20 table. Now remember, if the numbers are bigger, Google, just go to like a Google search and type in a 25 by 25 table, something like that, something that's going to give you a bigger table, right? But this is another way you can do it. And again, what a lot of people appreciate about this is that it's visual, right? You can see the numbers that we're looking at, okay? All righty. Okay, so next part here says, for any two non-zero whole numbers A and B, the greatest common divisor of A and B times the least common multiple of A and B is going to be equal to A times B itself. Okay, so let's see if we can figure out what they're asking me to do for these problems here, y'all. It says if the product of two numbers is 253, that's telling me that A times B is 2523, okay? And the GCD is 29. So the GCD of A and B is 29. We're trying to find the least common multiple of A and B, okay? So look, y'all, I'm just going to kind of fill in some blanks here, okay? I'm going to come back and I'm going to look at this formula right here. Now, the greatest common divisor, hey, we already knew that was 29, okay? Times the least common multiple, we don't know what that is, okay? Is equal to A times B, which in this case was 2523. So if I want to find the least common multiple, y'all, we can just divide both sides by 29. Okay. So look, I'm going to take my calculator, 2523 divided by 29, and that's going to give me my least common multiple, which in this case is 87. Okay. All right. So look, I'm going to do the same thing for the next problem. It says if the GCD of two numbers is 19 and their least common multiple is 285, if one of the numbers is 95, find the other number. Okay, So look, y'all, what I'm going to do, I'm going to write down the little formula again. The GCD times the LCM is equal to A times B, okay? So first off, they told me what the GCD was. They said that was 19. They told us that the least common multiple was 285. And they told us that one of those numbers, A or B, let's say it's A, was 95. We're trying to find B. So the first thing I want to do, y'all, I want to multiply those two numbers together. So let's take 19 times 285. That's giving me 5415 equals 95 with a B. And then we can just divide everything by 95. Okay. And so the other number, y'all, has to be 57. Okay. Okay, so next part here says classify each of the following statements as true or false where A and B are whole numbers. I'm sorry, it was 57 because we took 19 times 285, we came up with 5415, and then we divided it by 95, and we got 57. Good question. Look, y'all, it says classify each of the following statements as true or false where A and B are whole numbers. Look what it says. If the greatest common divisor between A and B is 1, then A and B cannot both be even. Okay, so let's think about that. Remember what the greatest common divisor means. The greatest common divisor is what's the biggest number that can divide into both? Well, let's think about it this way. Suppose A and B were both even numbers, right? If A was an even number, I'm going to pick a small even number, like say 2, okay? And let me pick another even number. I'll keep it real small too. What about 6? Wouldn't you guys agree that the greatest common divisor between 2 and 6 would really be 2? So there's no way it can be 1, right? So we're going to say here that it's true. Now the question is, which one am I going to pick? Am I going to pick A or am I going to pick C? So A says true. If the greatest common divisor is equal to 1, then either A or B is equal to 1. If you remember earlier, y'all, we did a problem, and I'm going to scroll back here. Forgive me for scrolling through all this mess. But we had done a problem earlier. I think it was over here. Here we go. We did a problem earlier where the greatest common divisor between those two numbers was 1. But it didn't mean that one of those numbers had to be 1, right? So when I come back to my answer choices over here, I'm going to scroll back again, forgive me. Oh, let's see if we can find it right here. It says A or B is equal to 1. That's not true. If A or B have no common factors other than 1, which implies they do not have a common factor of 2. That's the part that I'm going to use, right? Because it doesn't mean that that either one of those numbers had to be equal to 1. Okay. Okay, now there's the second part. It says if the greatest common divisor of A and B is 2, then they're both even. Y'all, we just did that right now, right? We said suppose A was 2 and B was 6. Their greatest common divisor is 2, and so they're both even. So again, this is going to be true. Now let's take a look because I got 2 answers that are true. It says if it's true, then both A and B have a factor of 2, and then they're both even. Yes, they both have a factor of 2. The second one says both A and B contain a square of a number. Well, no, they don't, because 2 is just 2, and 6 is 2 and 3, and none of those numbers are perfect squares. So I would pick choice C because they both have a factor of 2, and that means they're both even. Okay, so now look at the next one. It says if A and B are both even, then the greatest common divisor between A and B is 2. Well, that kind of looks like it's true because these were both even and their greatest common divisor. But I want to take a look at something, y'all. If A and B are even, let me pick some bigger numbers that are even. Like suppose I pick A to be the number, say 4, and I pick B to be the number 12, okay? So both of these numbers are even. right? They're both even because I can divide them both by 2. But is the greatest common divisor equal to 12? Well, remember, I can break that down into 2 and 2. We can break that down into 2 and 6, and that's 2 and 3. And oops, what do they both have in common? They both actually have 2 2s, so their greatest common divisor would be 4. So this is going to be false. Now I want to know, why is it false? I got 2 choices here. Let's see. If A and B are even, then the greatest common divisor will either be half of A or half of B. The greatest common divisor was not half of A, and it wasn't half of B. If A and B are even, then they both have a factor of 2, but they could also have other common factors that are greater than 2. Yes, that's what we're looking at. Okay. All right, y'all, we're going to skip this problem right here, and I'm going to pull it out of the homework so you don't have to worry about this next one here. It involves that Euclidean algorithm again, and it's not that it's difficult, but it's really, really tedious and very time consuming. Okay. Okay. So I'll make sure that I pull that problem out of the homework, and I'll do it as soon as I'm done with class, y'all. Okay, it says 2 numbers A and B are relatively prime if the greatest common divisor is equal to 1. Okay, so y'all, we did a problem earlier where we had the numbers 3 and 4. And 3 we couldn't break down, but 2 we could break down into 2 and 2. And so what we're saying is the greatest common divisor between, the greatest common divisor between these 2 numbers is equal to 1. All that means is that we don't have any common factors, okay? We don't have any common factors. So this question here, it's kind of a gimme question, but it's kind of confusing at the same time. It says, how would you show that this number right here, this looks like, let's see, that's 6,145,701,611, and 4 are relatively prime. When I say it's kind of a give me problem, because it tells you right here above, 2 numbers are relatively prime if their greatest common divisor is 1. So what we would have to do, we would have to show that the greatest common divisor is 1. That's all it's really telling me there, okay? Okay. So y'all, we've kind of actually done these problems before, but we'll go ahead and do it again. Again, it's just kind of review, but it says draw Venn diagrams to show the prime factors for each of the following 3 numbers. Okay, so let's do it. 10. I know 10 breaks down into 2 and 5, right? 15 breaks down into 3 and 5. And 180, it's going to take me a little bit longer to break down. 2 and 90. That's 9 and 10. That's 2 and 5. And that's 3 and 3. Okay. So, y'all, just like we did before, I'm going to go 1, 2, 3. Okay. And just like I did, y'all, that's going to be my circle for 10. That'll be one for my 15. And that'll be for my 180. Okay. So, first thing I want to do, I'm going to look at my numbers that I have here. And I'm going to write these out, 2 and 2 and 3 and 3 and 5. Right, 2 and 2, 3 and 3 and 5. Okay. Now, what I'm going to ask you all is, do all 3 numbers have something in common? What do you think? What do they have in common? 5, right? Okay, y'all, that 5 is going to go right in the middle here. Okay. Now, look, if we take away the 5 from the 10, that 2 needs to go over there, right? And if we take away the 5 from the 15, then that 3 needs to go over there. So then now, if I take away that right there, okay, let's see what else we're left with. We're still left with a 3, okay? Now, I want to figure out where is, we had also we still have a 3. Now, look, y'all, if I put a 3 right here, I want to ask you a question. Can I take away this 3 here and put it right there? Because if I take away that 3, say it's this one here. But this one had a 3, but so did 15. So look, here's 15 and here's 180. They also share a 3, don't they? So there'll be a 3 that goes into both of those. Now look, let's see. We have a 2 right here, so let me put that 2 over there. But this 2, 10 also has a 2. Couldn't I take away this 2 right here, y'all, and put that 2 right there? Because the 2 is common to both the 10 and to the 180. And there's all my numbers, and they all fit in like that. So there's a little bit of more overlap here, right? It's not like all 3 numbers don't overlap. There is still some overlap here, okay? And I want to show you something, y'all. Look, 10 were the numbers 2 and 5. There they are. 15 were the numbers 5 and 3. There they are. The 180 had 2 2s. So look, let me do the 180. I'm going to do it in yellow. Okay. So there's the 2 2s, the 2 3s, and the 5. And they're all in common, okay? So look, let's do the same thing for 4, 8, and 12. We're going to break down 4. 2 and 2. We're going to break down 8. 2 and 2 and 2. And we're going to break down 12. 2 and 2 and 3. Okay. 1, 2, 3. Okay. So the first thing I'm going to say is, okay, do all 3 of them have something in common? Yeah, they both got a 2 there and another 2 right there. Okay. So here's my 4, here's my 8, there's my 12. Okay. Now notice, y'all, there's nothing left for the 4s. For the 8, there is another 2. And for the 12, there is another 3. Okay. Okie dokie. So I think we got 2 more problems here left, y'all, out of 4.3. So let's finish these up. And it says, in Quinn's dormitory room, there's 3 snooze alarm clocks, each of which is set at a different time. Clock A goes off every 20 minutes. Clock B goes off every 75 minutes. Clock C goes off every 100 minutes. If all 3 clocks go off at 6 a.m., answer the following questions. Part A says, how long will it be before the clocks go off simultaneously again at 8 a.m. or after 6 a.m.? Okay, so let's see. Clock A, every 20 minutes, right? Clock B is every 75 minutes. And clock C is every 100 minutes. So they all start off, they all go off at 6 a.m. We want to know when's the next time they're going to go off, okay? So look, y'all, this one goes off every 20 minutes, right? So it'll go off at 6, it'll go off at 6:20, it'll go off at 6:40, it'll go off again at 60, at 80, at 100, at 120. Okay, this one goes off at 6, and then I know 75 minutes later, and then 150 minutes later, and then if I add another 75, 225 minutes later, so on and so forth, right? It goes off 100 minutes later, 200 minutes later, 300 minutes later. What I'm looking for here, y'all, is the least common multiple, okay? Now, one thing I could do, I could keep playing this game. I could just keep making my list longer and longer and longer, and that's one way to do it. Another thing I could do, I could break down my numbers, okay? So look, if I were to break down 20, I know 20 breaks down into 2 and 10, and that breaks down into 2 and 5. So I have 2 2s and a 5, okay? And then we could break down 75 into 3 and 25, and that's 5 and 5, okay? So 75 is a 3 and 2 5s. And then we could break down 100 into 10 and 10, but each of those 10s has a 2 and a 5. So 2 2s and 2 5s. Okay. All right. Now, to find my least common multiple, y'all, one thing we can do is we can say, do all those numbers have something in common? And it looks like they all have a 5, right? Okay, so they all have a 5. Now, this one has 2 2s, and so does that one. I'm not going to put down 4 2s, y'all. I'm going to put down 2 2s. Why? Because none of those numbers has more than 2 2s. I don't know if that makes any sense at all. What I'm trying to say is I'm looking at the number. I'm going to use each of the numbers that I have, but I'm going to write them down the most number of times that I have. Okay. And then let's see, what else do we need? We need an additional 5 because that one both had an additional 5. And we also need the number 3. Okay. So look, y'all, I'm going to multiply these numbers out. Oops. And let's go 5 times 2 times 2 times 5 times 3. And I'm coming up with 300. Okay. And I want to show you guys something. So we came up with 300, right? Look, y'all, there was 300 right there. If I added another 75 to this, that would have been 300. If we keep playing this game, this was 120, 140, 160, 180, 200, and we would get to 300 again, right? So that's going to be our least common multiple. And again, that's why I said you can do it by just making that list longer and longer and longer. And again, it takes time. There's no doubt about it. Or you can break your numbers down and find your LCM, right? So they're going to go off again after 300 minutes. Now, y'all, there is a second part to that question. Second part of the question says, would it be different if clock B went off every 20 minutes and clock A went off every 75? So all they're doing is they're calling that one B and that one A. But it wouldn't make any difference because my numbers haven't changed, right? So the numbers isn't going to make any difference. So we would say no, it's not going to make any difference, right? All righty. So this is, oh, 2 more problems. Okay, let's take a look. I thought it was 3. I thought it was 2 more problems, or 1 more problem, but it's really 3. Okay, it says if there's 12 boys and 8 girls at a party, and the host wanted to give exactly the same number of candies that can be bought in packages of 15, what's the fewest number of packages that can be bought? Okay, so we have 12 boys and 8 girls. Y'all, doesn't matter if there's boys and girls at the party. How many kids do we have total at this party? We got 20 kids, right? And the candies come in packages packages of 15. So we want to figure out what's the fewest number of packages of candy that we can buy. So we're really trying to do here, y'all, we're trying to find the least common multiple, okay? Look, let's break down the number 20. 20 is 2 and 10. 10 is 2 and 5, okay? So 20 has 2 2s and a 5. 15, y'all, is just 3 and 5, okay? So my least common multiple, I'm first going to find the number that we have in common, which is 5, and then whatever is left over. So we got 2 2s and a 3, okay? So 5 times 2 times 2 times 3 is 60, okay? So that means that we want to buy a total of 60 candies. Now, the question is not asking me how many candies do I want to have total. The question is asking me, what's the number of packages that we can buy? Well, if candies come in packages, y'all, of 15, and we want to have a total of 60 candies, what I would do now is I would take 60 and I would divide it by 15. And so we need to buy a total of 4 packs, right? If we have 4 packs of candies, then everybody can get an equal amount and we'll be good, okay? All right, so same kind of problem here, y'all. It says 3 motorcyclists ride around a circular course starting at the same place at the same time. The first pass is every 18 minutes, the second one every 27, and the third every 24. How many minutes will all 3 pass at the same time? Okay, we're going to do the same thing we did right now, y'all. We're going to find the least common multiple. 18 is 2 times 9, but I know 9 is 3 and 3, okay? 27 is 3 times 9, but I know 9 is also 3 and 3. And 24 is 2 times 12, but 12 is 2 times 6, and 6 is 2 times 3, okay? So we're still looking for the least common multiple. Okay. So y'all, when I'm looking for the least common multiple, what I would probably do again is say, what do they all have in common? It looks like they all have a 3 in common, right? Okay. So I need a 3. And then what I would say after that is I would say, look, which one has more 2's? Well, the 24 does. So I need 3 of those, okay? And then I would say, how many more 3's do I need? Well, which is the one that had the most 3's? This one did, but I've already used one. I only need 2 more, okay? So I'm only using the factors where I have them the greatest number of times, okay? So y'all, I'm just gonna multiply here. I'm gonna say 3 times 2 times 2 times 2 times 3 is 216, okay? So what did we find? We found the least common multiple right here, which was 216. All right. Let's see. Let's keep moving along here, y'all. I guess I had more questions than I thought. Is there another one after this? Okay, there we go. So these are the last two. All right. So let's take a look here, y'all. It says Anna made 42 chocolate chip cookies and 24 sugar cookies. She wants to put them in bags for her friends with the same number of cookies in each bag. The same kind of cookies in each bag with no cookies left over. What's the greatest number of cookies she can put? Okay, so look, y'all, if we have cookies, right, and we're going to put them into bags, that means we're dividing, okay? And then the next thing it says, what's the greatest number of cookies? I'm really looking for my greatest common divisor between 42 and 24. Okay, so we can find the greatest common divisor. We've done this before. 42, I know, is 6 times 7, and 7 is 2 times 3. Oops. So 42, y'all, is 2 times 3 times 7, okay? Let's do the same thing for 24. 24 is 2 times 12. 12 is 2 times 6, and 6 is 2 times 3. So this is going to be 1, 2, 3, and a 3, okay? Now, if we're looking for the greatest common divisor, y'all, we're looking for the numbers that we have in common, and that's going to be 6, okay? So just to give you an idea here, y'all, what told me that I was going to look for the greatest common divisor was when I read the question, what's the greatest number, right? So what's the greatest number? That tells me I'm looking for the greatest common divisor, okay? And the fact that we're taking those cookies, excuse me, and we're divvying them up, okay? All righty. Okay, this is the last problem. It says the front wheel of a tricycle has a circumference of 63. The back wheels have a circumference of 27. If points P and Q are touching the sidewalk when Mahmoud starts to ride, how far will he have ridden when P and Q touch the sidewalk again at the same time? Okay, we're looking for least common multiple, y'all. What's the least common multiple between 27 and 63? Okay, so look, let's take 27. Let's break that down. That's 3 and 9, but 9 is 3 and 3. So I got 1, 2, and 3. Okay, 63 is 7 and 9. And I can't break down 7, but we can break down 9 into 3 and 3. Okay. Okay, so the way, again, we find the least common multiple, y'all, a couple of ways you can do it. 2 ways. One way is look at which one has more 3's. Well, 27 does, right? And this one has more 7's. So I'm going to go 3 times 3 times 3 times 7, which is giving me 189. The other way we could do it, y'all, and again, I want you to figure out which way works easier for you, is to say, what numbers do we have in common? The 9. What else was left over? This 3 here and that 7 over there. And if I take 9 times 3 times 7, I still come up with 189. Whichever way is easier is the way that I want you all to do it, okay? And so they'll have written 189 inches, right? And that's the number that I'm going to put right there. Okay, y'all, so I told y'all, let me go ahead and stop recording real quick. So let's go like this.